So the Tomasulo with reorder buffer, the first few steps are very similar to without the reorder buffer. So issue step is going to uh, detect if there is any structural hazard in the reservation station. So basically it is going to dispatch the instruction to the reservation station, and it's also going to dispatch it to the reorder buffer to make an entry in the reorder buffer. And this step also reads registers for source operands. So this happens while it is while it is in the reservation station. And if the source operands are not available, it is going to wait. Now, these source operands will usually come over the common data bus, and this can also come from the reorder buffer. So I'll show the structure which is going to come from the reorder buffer also. So then the execute is very similar. The execution unit is going to execute the instructions, and it is going to monitor. Then there is also a monitoring of the common data bus for the operands. So basically the reservation station is going to monitor the CDB if the operands are available. And similarly, there is also the execute, the ALU is going to execute the instructions. Now, this particular sentence I'm going to explain when I explain the example. Then finally, it is going to write the result after execution is complete. It's going to broadcast the result on the common data bus. It is going to broadcast it to the reservation station and also to the reorder buffer. And all the operands are going to be captured here in the reservation station, in the reorder buffer, and also in the load store buffers. Then the last step is commit, which means from the reorder buffer, the data is going to get written to the architectural register file. And this is going to happen in order. And the pointer, the head pointer, is going to keep track of which instruction to commit to the register file. And once that is done, the instruction is removed from the reorder buffer. So let us go through a step by step, a cycle by cycle for these set of instructions. Let us assume these delays. I'm not showing the structure of the Tomasulo because we've seen it already. So let us assume 2 units of delay for load, 10 for mul, 40 for div, and 2 for add. Let me first explain the structure in this slide, which is slightly different from what we saw earlier. So I'm showing the architectural register file also, although I have actually shown nothing here, but this is just for the sake of completion. There is what is called an architectural register file. This is going to point to the RRF or to the RAT, which is the register uh, allocation table used for renaming. Then this table is going to tell us in which cycle the current instruction is in, and this is the issue step. This is the execution start, execution complete, write result to the CDB, and the final one is commit. So for lack of space, I have just written it in brief. So this is issue, execution start, execution complete, write to the CDB, and commit. Then these are the reservation stations. So we are assuming 3 reservation stations for add or sub. All of this is add or sub, and then 2 for mul or div. There are also load store buffers. These are nothing but kind of reservation stations for the load or the store instructions. And this is the reorder buffer shown here, which is, we are assuming there are 6 of them. One of them is not shown here. So this is ROB 5 and ROB 6. There are 6 entries in the reorder buffer. This contains the instruction, destination register, and the value. The reservation station, as usual, contains the busy tag, the operation that is going into the reservation station, the 2 sources if they are available, and 2 of them if they are waiting. So let us start the first cycle. In the cycle 1, the first instruction gets issued. When we say issued, it's actually in the correct terminology, it should be called dispatch, but in the Tomasulo terminology, it's called issue. So it's getting actually dispatched to the reservation station. So we make an entry here, and we also make an entry for the address that has to be computed. So the address that has to be computed is 32 plus R2. So in the meantime, we also make an entry in the ROB. So this is something new which was not there earlier. We make an entry in the ROB for the instruction. We write down what is the destination, and the name for this instruction, or actually for the destination, the new name is ROB1. So what we are going to do in the register allocation table, in the rename table, is that we are going to rename the destination as ROB1. So let us also remember that the first step is actually we read the sources. So the sources were 32 and R2, and they were written here. So they are available. So ideally in the load buffer, there should have been an available and waiting field similar to what we have here. So basically R2 has been read. R2 has been read from the architectural register file because it has not been renamed. And so basically next cycle it can start execution. So that was read sources. The next is destination rename. So these are the steps in register renaming. So destination rename, F6 is the destination here for load, and that has been renamed to ROB1. So these are the steps which we are going to repeat for every instruction. So we have to understand first step, we issue it to the reservation station. Second step, we look up the sources in the RAT, and then we find out if the sources are available. Third step, we're going to rename the destination to the ROB entry. So before that, we have to make an entry in the ROB, and then change the destination name to the ROB entry name. So these are the steps we are going to follow. So cycle 2, because the sources are available, load can start executing. So load can start the moment the load starts executing. What we can do is actually we can free up the reservation station. We no longer need the tag, because we already have the tag in two other places. And so the two places where we have the tag is one, we have the instruction to the rename connection here in the ROB, and we also have it here in the RAT. So later on, even if F6 were to get renamed to something else, let's say ROB3, we will still have that connection in the ROB here. So we can actually free up the reservation station the moment we issue the instruction to the execution unit. So this is another difference between the previous algorithm without ROB and with the ROB. So the next thing that happens in cycle 2 is the second instruction can get issued. So remember, we are only doing a single issue per cycle. So therefore we can only issue one. And we are also doing in order issue. Therefore we always follow the same order for issuing instructions. So what we do by issue, we again assign it to a reservation station or the load buffer. It's a load instruction. We find out if the sources are available. So R3 is available. It's not renamed. Therefore, they're available, which means you can start executing in the next cycle. We make an entry in the ROB, write down its destination, and rename the destination, which is F2, in the RAT. So we make an entry in the ROB2, and then we assign the rename ROB entry, which is ROB2, to F2. So these are the steps that happen in cycle 2. So load has started executing. We know that load is going to take 2 cycles, which means cycle 3 it's going to complete. So cycle 2 and cycle 3, it's used for execution. It's completed in cycle 3. So let us go instruction by instruction in cycle 3. Load has completed. The first load has completed. So it has completed execution. It has not yet returned the result to the CDB. So we just hold on to it till the next cycle. What is happening with the second instruction is its operands were available last cycle. So we can start executing in cycle 3. And because we have started executing in cycle 3, we can now free up its reservation station also. And that is what is happening with the second instruction. Now the third instruction, as usual, gets first the reservation station entry. It's a multiply instruction. It's a multiply instruction. It gets a reservation station entry here. We read the source operands. Okay, before that, uh, let me reiterate the steps again. So first, it gets an entry in the reservation station, and it gets an entry in the ROB. So ROB entry is made. So when the ROB entry is made, we look up the source operands F2 and F4. We always look it up. Of course, first thing we look it up in the ARF. I have not actually shown the ARF to RAT connection here. Ideally, I should have shown. So when you look for F2 here, you should find this tag here, the connection to the RAT. So basically it is ROB2 and it is waiting on ROB2. That is why we make an entry here in the waiting column that it is waiting for ROB2. That is basically it's waiting for F2. And the F2 is going to come from load. Then what about F4? You look up again in the ARF. This does not have any tag here. So that means it is available. So we make an entry here in the available column. So this is available and this is waiting. So we make an entry in the available column that F4 is available. And lastly, we do destination rename. So destination is F0 and that F0 is going to be renamed to ROB3. So these are the steps that happen in cycle 3.